Now we're going to go over the second part of section 8.2 of special right triangles, which is the 30, 60, 90. First of all, just to see where this comes from, when an altitude is drawn from any vertex of an equilateral triangle, two congruent 30, 60, 90 triangles are formed. So if we think about an equilateral triangle, we know is a triangle that has all three sides congruent to each other. If all three sides are congruent, then therefore all three angles must be congruent as well. And since we know all the angles of a triangle add up to 180, then we know all of these angles must be 60. So this one's 60, this one's kind of shifted over a little bit. You know, this 60 is referring to right here, and so this whole angle is 60. But if I draw an altitude from this vertex down to this side, that means that these are both right angles. I just split this 60-degree angle into two, and now I have a 30 and 30. And so now it's just saying two 30, 60, 90 triangles are formed. So I'm going to move this up, and then we're just going to deal with one of those 30, 60, 90 triangles at a time. Okay. So if we look at this, the theorem says in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. Okay, so if we label this triangle to help us see this a little better, we can see that across from the smaller leg is going to be the 30-degree angle, like we saw in the previous picture. And across from the longer leg is going to be the 60-degree angle, okay? And if we get these side lengths labeled, if it is helpful to you, again, across the right angle is the hypotenuse, across from the 30 is the short leg, and across from the 60 is the long leg, if that helps you to get that filled in. All right, now, if we think about it, what this is saying is if we knew the short leg was the length of 1, we said the hypotenuse is 2 times the length of the shorter leg. So if the short leg is 1, the hypotenuse is 2 times bigger than that, which would be 2. And then it said that the longer leg is square root of 3 times the length of the shorter leg. If the short leg is 1, I would multiply by square root of 3 to get the longer leg. Okay, that's just kind of the relationship between them. Instead of the 45, 45, 90, you know, just had kind of that one number to think of, the square root of 2. Now we've got 2 different relationships we have to think of here. Okay. For some people, it's helpful for them to think of it as a little formula. And so for some people, it is helpful for them to think of it as the hypotenuse is equal to 2 times the short leg. Okay. And the long leg is equal to the short leg times square root of 3. So if it helps for you to think of it as a formula type thing, you can. I generally just think of it as, I know these are my 2 relationships. I know the relationship between short leg, long leg is square root of 3. I know the relationship between the short leg and hypotenuse is 2, and then I just think about, am I trying to multiply or divide to get a bigger or a smaller number? I know that if I'm going from short leg to long leg, I'm trying to get a bigger number, so I multiply. If I'm going from long leg to short leg, I know I'm trying to get a smaller number, so I divide. I know the hypotenuse is always the biggest side of a triangle, so if I know I'm going short leg to hypotenuse, I multiply by 2. And if I'm trying to go to hypotenuse to short leg, I would divide by 2. So there's different ways that people like to think of it. That's the way I do, but you're welcome to use the formulas if that's helpful to you. Okay. All right, so if we look at example 1 here, then on this case, if I see the 90 and the 60, I like to go ahead and just fill in the 30 here. And then, again, I think it's helpful for people, especially at first, to label your side lengths. I know across the right angle is my hypotenuse. It doesn't take long. Across from the 30 is my short leg, and across from my 60 is my long leg. Okay. From there, I have to think about it, and I have to think, okay, I know the hypotenuse, and from that I can get the short leg. here's the thing we haven't mentioned yet. You cannot go straight from hypotenuse to long leg. There is no relationship. So I have to go this direction to short leg, and then I can go from short leg to long leg. So if I know the hypotenuse and I'm trying to get the short leg, I know I need to get a smaller number, so I know I need to divide. I have to think, what's that relationship that I need to divide by? And it's 2. So to get the short leg, from the hypotenuse, then I need to go 14. Oops, here we go. I need to go 14 divided by 2, and that gives me 7. And when I find it, I'm going to go ahead and put it on my picture, because I think that's going to help me find the next thing. Now I need to think about it. I'm going from short leg to long leg, so I'm trying to get a bigger number, so I'm going to multiply, and I have to think, what am I going to multiply by? What's the relationship? It's square root of 3. So therefore, the long leg is 7 times square root of 3, which gives me, obviously, 7 square root of 3. All right, and then these are the 2 answers of, actually, they're just asking this time for AC, so I really didn't need to circle the 7. But again, what I pointed out to begin with is that I could not go straight from the hypotenuse to the long leg. I had to find the short leg first and then transfer that to the long leg. Okay. All right, so let's try another one. On the next one, on example 2, get this moved up. You can be looking at that, filling in any missing angles until we get started here. So on that, find the length of AB. So again, I think it's very helpful to start with just filling in our angles, any missing angles. Also labeling my side lengths. Across the right angle is my hypotenuse, across in the 30 is my short leg, across in the 60 is the long leg. Keep in mind sometimes the figures are flipped or turned, maybe from your other example, and so you just need to kind of get that framework down first. From there, I can look at it and think, okay, this time what's across in the 60 is my long leg, and I know my long leg, and I'm trying to figure out what my short leg is. So I'm going to try to get a smaller number, so I therefore need to divide. What do I divide by? Is square root of 3. So to figure out what AB is, I need to do 4.5 square root of 3, and I need to divide by square root of 3. If I divide by square root of 3, then I can just cancel out these square root of 3's. That makes it nice and easy. And then I am left with 4.5. And, you know, that's all that it's asking me to do on that one. Okay. I found the length of AB and I'm done. Okay. Just for practice, if you wanted to find the hypotenuse, then again, I think, okay, I'm trying to get a bigger number, so I'm going to multiply. What's the relationship? It's 2, so I just need to multiply by 2. So if you wanted to go further, you would just go 2 times 4.5 to get 9. Okay, but it didn't specifically ask you to on that one. All right, on example 3, let me get that cleared. And go ahead and start looking at that. Again, filling in any missing angles to start with. And you can see here it says find the length of QR. So again, here's my 90, here's my 60, here's my 30. And from there, again, I think it's helpful to say, okay, across from my right angle is my hypotenuse, across from my 30 is my short leg, and across from my 60 is my long leg. Okay. From there, I can see they will be to find the length of QR. So QR is here, but what they're giving me is the long leg. So I need to first find the short leg before I can find out what QR is. So the short leg is equal to 6. Now I'm trying to get a smaller number. The short leg's always smaller than the long leg. So I'm going to divide. And what's the relationship between the short leg and the long leg is square root of 3. So I'm going to divide by square root of 3. Again, I'm not allowed to leave a square root in the denominator. So I can think of my algebra rules, and I could multiply by square root of 3 over square root of 3. And that gives me 6 square root of 3 over, remember we talked about a minute ago, square root of 3 times square root of 3 is square root of 9, but the square root of 9 is 3. That's my shortcut. And then I can go ahead and reduce that down. 6 divided by 3 is 2 square root of 3. And that gives me what the short leg is. So I'm going to go and put that in my picture. But that's not what the question is asking for. The question is asking for QR. So again, I have to think from short leg to hypotenuse, do I multiply or divide? Oh yeah, I multiply. What do I multiply by is 2. That's the relationship. So to get what QR is, I can go 2 times 2 square root of 3, and that gives me 4 square root of 3. And that's the answer that they were looking for here. Okay, and one more. So if we go ahead and clear that, then on example 4, it says that the perimeter of an equilateral triangle is 45 centimeters. Find the length of an altitude of the triangle. State the exact answer. So they didn't give us a picture this time, so we can make a picture. We can draw an equilateral triangle. Okay, and it says the perimeter is 45. So if I think about what that means, if the perimeter, the distance all the way around is 45, and I want to know the length of one side, then I know that I can go 45 divided by 3 to get 15. Okay, so I know each of these sides are 15. Okay, I also know that all of these angles then are 60. Okay, because if all the sides are congruent, all the angles are congruent, and they all add up to 180, so they all have to be 60. But if I have an altitude drawn down through the middle, then that makes these angles 30 and 30. It's divided up. Okay, it's asking us to find the length of the altitude. So we'll call that A for altitude. And you know, I can do that. I know that this length from here to here is 15. So think about what this would be from here to here. Okay, I know it's going to be half that, which is 7.5. I also could have done it by the fact that this is the hypotenuse and this is a short leg, and I know the relationship is 2, and I would divide that by 2. So either way you want to think about that is fine. And now I know that this is the short leg, and this across from the 60 is the long leg. And again, I'm trying to get a bigger number, so I'm going to multiply. And what's the relationship that I multiply by? Square root of 3. So I can say that A, this altitude, is 7.5 times square root of 3. Okay, and again, the way I write that, you know, you don't have to write it like this. You can go ahead and just write 7.5 square root of 3 and be done with it. But if it just helps you to think through that, you can. Again, if you have any questions or need any help with this lesson, feel free to contact me and I'll help you get it figured out.